Hello, so I'm coming at you from the future again. So we're going to finish up the branches this week, the branches slides, and then we'll also start loops. And one thing that you'll notice, and that you've probably already noticed, is that I have a ton of examples, and I like to throw a bunch at you, probably more than I would be able to in a normal semester. The point of them is not for you to memorize it, any of them. It's not that I want you to know that the rand function lives in the C standard library. That's something that everybody looks up. You don't have to memorize that. All of the examples that I give, though, are just examples of computational thinking, because that's the underlying thing I'm trying to teach you right now. Okay, it's not every little concept, every little function in every library that I'm trying to make you learn. Okay, those are things that you can look up. So this is all really to prepare you for your labs and Xylabs, because every test in this class is, of course, open book. I can't come and watch your computer as you take it. So yeah, hopefully you're enjoying the examples. I do switch between weird ones kind of abruptly, but that's just to get as many in so that one will stick with you. And don't feel like you have to follow every single one of them. You have to recreate every single one of them on your own. But hopefully they're a bit helpful. That is the idea. So now, let us continue with the normal lecture part. Alright, hello and welcome to week 3. We stopped last time on these slides, so we'll continue them, talking about branching, doing one thing or another, and combining things as well. Well, let's continue. So we were talking about the Boolean type, the bool type, sorry that is hard to read, and what it can do is store true and false things, and we can combine true and false values in different ways. So we talked about and, what it means to do one thing and another, make sure that both are true. That's what makes B1 and B2 true. So just to give a bit of a recap, let me just give a quick example of using and again. Alright, so this is just a simple example. So to determine whether or not we should bring an umbrella today, I realize it's August and it's currently the hottest day right now, so wouldn't it be nice if it were raining? But let's ask the user, hey, is it cloudy today? And is there a chance of rain? And maybe, just maybe, if both of those things were true, then we should probably bring an umbrella. That would make sense to do that. So yeah, let me make sure I press record. I don't immediately remember that. Okay, so we're good, and let us make this program. So, bring umbrella, we can call it .cpp. I can get rid of that, I think. Now, alright, I'm in my home folder. I got stuff here. Let me get to the code from class folder, which is in my Windows desktop folder. Inside of that, it's in my code from class folder. Inside of that, it's my CSCI 4D folder. And now we need to make a new folder for today. So make dir lec05 in this directory, hit enter. Now I have that empty folder. Let's go on into it. There's nothing there, but this is my full path. And let's make our first file. So vim bring umbrella .cpp. So let's do this. Let's be like, hey user, hey user, is it cloudy today? And they can answer yes or no. So we'll get their answer in a string form. So see in that. So now we have it. And then we'll do the same for is there a chance of rain? Because if both of those things are true, then we should totally bring our umbrella. Yeah. So let's check that. And so I can pretty much copy and paste what we're doing here. So is there a chance of rain? And this will be another yes or no question, so it'll be yes or no 2. And now we have that as well. So we have a yes or no 2, as well as a yes or no 1. And we want to bring an umbrella if the user typed both. So if yes or no 1, the first answer that the user gave us, is equal to yes, and yes or no 2, the second answer, is there a chance of rain, is also equal to yes, in that case, we should say, yes, let's bring an umbrella. Okay. And in another case, we can just have it fall through and say nothing, or we can use an else and say, you probably don't need an umbrella. So maybe if there was a chance of rain, but there's no clouds in the sky, maybe the weather was wrong, we don't have to bring an umbrella. Maybe it's cloudy, but there's no chance of rain, so there's, again, no reason to bring an umbrella. And so that goes back to this table again, all the ways that it could be false, and the one way that it could be true. Okay, so if we care about that combination, we'll use the AND to mark that. Okay? And I forgot the semicolon there, sorry about that. And let's go ahead and compile and run this program. Boop. Just like that. So, G++, CN equals C++17, bring umbrella. Remember, you can type tab for it to autocomplete things for you if you just type a little bit. -O, and we want to call it bring umbrella, just like that. Let's run it. So is it cloudy today? It is actually cloudy today, but it's just hot. There's no rain chance of rain though. And I forgot a space there, so the user's gonna type right next to that question mark. That's no fun. So sorry. So you don't need an umbrella probably. But if it's cloudy and there's a chance of rain, you should bring an umbrella. Alright, so that's the idea. Your if-else statement, our AND. Hopefully that's making sense to you. And now, let us combine conditions with a different kind of combinator. So we talked about AND. Now let's talk about OR. Okay? So do things when one thing is true or some other thing is true. Alright, so what's a good thing with an OR statement? Let me take a second to think. So perhaps you want to bring an umbrella if there's a chance of rain or it's currently raining. Yeah? How about that? In either case, and even in the case where both are true, we want to bring an umbrella. Yeah? So after all of that, we should be like, if any of those two are true, then bring an umbrella. Okay, that is the idea. So if there's a chance of rain, or it's currently raining, then we should bring an umbrella. And the OR operation, the OR operator, does just that. It checks those things. So here is A, here is B, and here is the result of A or B. So you read that as OR. So A could be, what are my combinations? I always do that, but the common way to do it is false, 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 true, true, false, and true, true. Okay, so in either all of these cases, we're checking is something or another thing true, and so false or false. Are any of those things true? No. So A or B is true, or is false, sorry. A or B, false or true. Is one of those things true? Yes. So A or B is true. True or false? Is one of those things true? Yes, true. And this is an interesting thing. True or true is also true. So if there's a chance of rain, or is it currently raining? Are any of those things true? Yes, we say true. And this is separate from like your mom telling you, hey, for dessert you can have a cookie or a brownie. You can't have both, though. That's the implication. This OR operation, it's okay to have both. All right? So both is okay. And so now let's use this OR operation to check whether one thing or another thing is true. So I'm going to probably copy all of this, and let's see here. Make a new file called bringUmbrellaOr.cpp. So, is it currently raining, and is there a chance of rain? If the user answered yes to either of those questions, then we should advise them to bring an umbrella. I think you would agree. So, not and anymore, but or. So if they answered yes to either of them, if the first thing's true or the second thing is true, then we should say you should probably bring an umbrella. Otherwise, you probably don't need an umbrella. So, this is or. Is it currently raining? No. Is there a chance of rain? No. That is the only case where you probably don't need an umbrella. Because of the or, if any of them is true, we'll tell the user to bring that umbrella. Alright, so in any other case, is it currently raining? Yes. Is there a chance of rain? No. Bring an umbrella. Is it currently raining? No. Is there a chance of rain? Yes. Bring an umbrella. And yes for both of them, totally bring an umbrella. Okay? So that is or, and I hope you see the difference between that and you can combine and or to do fun things if you have like 3 things you need to compare. So this is just different ways to combine true and false to do what you want. That is or. Okay? Dun dun dun. And then the final one, the missing piece, is creating the opposite condition with not. Sometimes it's easier to think about something. Sometimes it's easier to ask when something is false rather than when something is true. And so, you can use not to negate. A condition. That's what we say. That's what not does. It negates a condition. And so, if you had your Boolean value set to true, however you got it, maybe it was an equals statement, maybe it was like a less than statement. If it was false, or if it was true, here's what would happen. Not A would be set to, in the false case, true. Not A in the true case would be set to false. So it does the opposite. So it transforms, it negates a condition. So what is false becomes true, what is true becomes false. And so, let me show you a few examples. First of all, let's say that I have A less than B. Okay? I want to know when that is not true. Okay? So I want to say, when is it not true that A is less than B? Okay, that's the way that I want you to read that. So when is it not true that A is less than B? And for these relational operators, there's a bit of a trick. So when is this false? Is the same way of asking that. So when is it false that A is less than B? Well, when the opposite is true, when A is greater than or equal to B, then this condition is true. So these are equivalent things. And I want you to check that. The opposite of a relational condition is flip it and then add an equals sign or take one away. Alright, so let's give some examples. So here is A less than B. Let me give some examples of A, B, A less than B, and then not A less than B. Whee. Well, if A is 40, B is 42, A less than B is true, and not A less than B is false. if the opposite is true, 42, 40, then A less than B, well, no, A is greater, so this is false. And so this is true. You see that? And it's also true if they're the same. Is A strictly less than B? 42 strictly less than 42? No, that's false. And so not is true. So I hope you see now why this is the same. It's equivalent to A greater than or equal to B. These are equivalent. Okay, so that's something for relational operations. And yeah, I think that's where I want to leave you there with not. So let's give just a quick example. Dun dun dun. I'll just add it to the OR program. So we can say if yes or no 1 equals to yes is false, then we can say you said it's not currently raining. Okay, so that is an example of using not to get the opposite condition. So when is it not true that yes or no 1 is equal to yes? Alternatively, you could have said yes or no 1, oops, not equal to yes. Okay, so negating an equality becomes a disequality. Okay, so when is it not true that yes or no 1 is equal to yes? Well, that's when it wasn't set to yes, when it was either no or just some random string of values. So I can type ASDF, and it will be interpreted as not equal to yes. Okay? And if you type yes, then that if statement does not get executed because it was true that yes or no 1 equals to yes, and so the negation of that becomes false, and if false is what this is saying, and so of course it doesn't execute its body. Okay? So negation, that will come up later, I think. And now finally, I want to talk about this thing called precedence. And so I've shown you some pretty benign conditions so far. It's been like A is less than B, I don't know. The most I've done is combine 2 things, right? But it's going to get worse, I promise. Greater than C, or C is C mod D is equal to 15. Things like that. So once you have long conditions, it becomes important, and also just long operations, like, I don't know, 5 times 7 mod 3 plus 4? This makes more sense because it's kind of from your math classes, you know the order of operations there. So we want to know, how is C++ going to execute this statement? What is the order of its operations for and or and things like that? Because it might be different if it did that as opposed to that. Okay? That might do something completely different. And so we need to know the order of operations that C++ is using. And in programming lingo, they say, instead of order of operations, we say precedence. So the precedence rules are what we're going to look at, and that tells us what happens first. Okay, so, and I'm going to show you these rules in a second, but in order of precedence, each operator in this list that I'm about to show you, it takes the smallest thing, the smallest unparenthesized or parenthesized possibly thing that it can, to the left and right of it, and let's give some examples now. Let's actually use these. So I'm going to open up the table now, and let us go to it. Boop. Boop. All right, so here it is. This is called the precedence table. and I'll try to remember to give this to you, but at the top are the highest precedence things, the things that happened first. Okay? So you have ... we know about ++, that apparently happens first before any other things, and everything in this group has the same precedence. Okay, so it's just left to right at that point. Okay? And so let us consult this table. So higher precedence things get done first, lower precedence things get done last. Let us consult this table to figure out how C++ will parenthesize our operation, or parenthesize our operations. That is a lot of words. Okay, so this first one, for example, let's see if I can copy this. Copy both of these, and so we can make them, give them some space that they deserve. Dun dun dun. Oops. Give me that lasso back, please. So now, that one's the first one. Let's do that because it's probably the easiest. And then we'll do this one. Okay? Alright, so our job is to figure out how C++ draws the parentheses. So let's look for all the operations that exist in this statement. And maybe I should make these a bit more clear. This is that. That is just a normal plus. That is a number 4. Okay? So here are the 3 operations that exist in this C++ statement or expression, and it's our job to figure out what's going to happen first and draw the parentheses. Okay? So, consulting the precedence table, which of these do we see first? Dun dun dun. It looks like we go all the way down to here, multiplication, division, and remainder in the same precedence group, which means that we'll do those from left to right as we see them. So this one will happen first, then this one. Okay, and so the rule is find the smallest thing to the left and the right of that operation, and that will be what it works on. So the smallest thing I can grab to the right of this star is not this, it's not this, it's just the 7. Okay, and then there's only one thing on the left. So this is what happens. 5 times 7 happens first, and now we've completed that first operation. And so now the next one is this modulus operation. So that will take, because we're following the table, we found it right there. It was to the right of a multiplication, so we just do all these in order from left to right, just like that. And so this one grabs the smallest thing that it can to the left and the right. And so it can't like do this anymore because we already, because this guy is now a group. Okay, so we have to do something like this. We got to take this, that's the smallest thing we can grab to the left, and this is the smallest thing we can grab to the right. You see that? That's the idea. That's how you read this. And then the last thing is the plus operation, and we can find that it's down here. It's after the multiplication, division, and remainder operations. We do addition and subtraction from left to right. But this one, we don't really have to do anything extra because already there's only a 4 to the right, and then there's this whole big thing to the left. That's all we get. Okay, so hopefully me walking through that makes it a bit more manageable. And so these are like the rules of like your PEMDAS from high school, your order of operations, plus some extra stuff that are C++ specific, okay? That are programming language specific. All right, so now let's do this one. Let's parenthesize it. Okay, so let's look for the operations. There's one, there's one, there's one, there's one, there's one, and there's one. Okay, that was a lot. Let me actually rewrite this because we're going to have to draw some parentheses in weird places. It's probably too close. Okay. So now let us consult the table for all of those operations that we found. Let's figure out how we're going to do this. Okay. So if you stare at this table long enough, I think you will see that the first thing that we need to do is this modulus operation. Okay, this remainder. So it'll take the smallest thing to the left and the right of it, so it's not going to take this whole darn thing, and it's going to take the C. That's all it's got. That's the smallest thing it can take. And then the D. Alright? So then the next thing, just working down the table, boop, 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 are these relational operators. They're in the next group. Okay, so we're going to take less than, greater than, all the other ones. So here's a less than. We're going to do them from left to right, because we have multiple. We do them from left to right. So this will take the smallest stuff that it can. So, for example, it's not taking this. It's taking just the B. And then this one will take the B and the C from the left and the right. Okay, moving on. Equals and not equals tests. This one. What's the smallest thing it can take on the left? This. Smallest thing on the right? The only thing on the right is that. Okay, I hope this is making sense. Alright, so that's how the parentheses will be drawn there. And now the only things we haven't considered are the ands and the ors. So what's the order of those? Well, and comes first. You parenthesize the and, you do the and first, then you worry about the ors. So, it works like this. The and gets parenthesized, takes the smallest stuff that it can to the left and the right, and then the or happens. And the or is already correct, because that's what it gets. That's what it gets. Okay? And I promise you that different things happen depending on the order of operations. These ones are specific. By following this table, things happen differently. All right, now time for an example. So please take a second, pause this video, and try and figure out, draw these parentheses, try and figure out what this evaluates to. And this one evaluates to, true or false. Of course, you can always write a program to check yourself, but we're going to do it on paper. All right, assuming you're back now and you have answers, let's check them. So, if x, well, let me draw some parentheses really quick. Dun dun dun, and then the and happens before the or. Then here the or happens before the and. And I think we can probably understand the rest. Okay. Now, so this is going to do this check first. X plus 1 less than 8. So x plus 1 is 6. Is that less than 8? Yes, that's true. So it'll be true or whatever this is. All right, so b and x greater than 5. Is b true? Yes, so true. And is x greater than 5? Those are some horrible ampersands. Is x greater than 5? Well, no, that's not true. That is false. X is equal to 5. So this becomes false, and you didn't really even need to check this side, because if you have true, true or with anything is true. So that is true. A. All right, how about this one? Well, this is going to be true, or B is true, and is x greater than 5? Ooh, that's false. And in order for an and, because that's the last thing we're doing, and in order for an and to result in true, both sides had to have been true. This side is true. True or true is true. But and false, that makes the whole thing false. So, this is why we learned precedence. Because if you just type this out and expect one thing to happen without any parenthesization that you put in yourself, you might get bitten. Because this default one does something, and this other one does something completely different. All right? So just keep that in mind. Consult the precedence table if you're ever worried, but just probably the one thing that I want you to get out of this is and comes before or, and we say that and binds tighter than or, we say. It happens first. Okay. So just try to remember that, and with that, we get to do some fun stuff now. All right, I'm excited. So extended examples, this is where we were trying to go. We're going to have some fun. So FizzBuzz is, it used to be a very common interview question just to make sure that you knew how to do some type of programming. This is what it is. So given a number n, print fizz if n is divisible by 3. Okay, so we'll take an n from the user, and then we'll print fizz if it's divisible by 3. All right, then we print buzz if the number is divisible by 5. So if we got 5, we'd print buzz. And then we print fizz buzz if it's divisible by both 3 and 5. So in this case, 15 would be printing fizz buzz because it's divisible by both 3 and 5. It's 3 times 5, in fact. All right, and if nothing is true, just print n normally. So 1, it's got nothing. 4's got nothing. 2's got nothing. Like 8 has nothing. We'll just print the number in that case. Otherwise, we're going to do fizz buzz or fizz buzz. Okay, so that is the name of the game. And let's just remember how to check for divisibility by something. So we've done this with even and oddness. So remember that even and odd checking is equivalent to checking for divisibility by 2. So you've already done that. So if I want to check if n is divisible by 3, my Boolean expression is n mod 3 equal to 0? Because that means n went in cleanly. All right, so for example, if n is 6, that means n mod 3 would have to be 0. Why? Well, remember what the remainder calculation is doing. If you divide 6 by 3, it equals 2, remainder nothing. Yeah, it went in cleanly. That's the idea. There's no decimal places. It's 2.0. Okay. Hopefully that makes sense. So that's how we check for divisibility. All right. So with that, we know how to print fizz. Okay. Let's do that. I'll make a new file called fizzbuzz.cpp, and pay attention because you're going to do something similar to this in your lab. So we're going to get a number from the user. We should probably output something first, and let's get it. We call it n. So now we have it, and now we'll do stuff. So if n is divisible by 3, print fizz. If it's divisible by 5, we're going to print buzz. And if it's divisible by both 3 and 5, print fizz buzz. All right, so let's do the fizz part. So if n mod 3 is equal to 0, we're going to print fizz. And if that's not true, we'll just be printing n itself. All right, so that's our first part of fizzbuzz. So we got the fizz part down, I think. So if we put in 3, we should get fizz. If we put in 4, we should get 4. So 3 fizz, 6 fizz, 12 fizz, 2. We just get 2. All right, that's the idea. So now let's do the buzz part. Sorry, forgot to say buzz. All right, so if it's divisible by 5, we print buzz. And so this is a different option. It's not this case, and it shouldn't be this case either. This is if nothing happened, if nothing succeeded. Just print the number. Now, so we want to do something before this. I hope you see that. And so we want to do that case splitting. So we'll say else if. Okay? So else if n mod 5 is equal to 0, then I'll print buzz. Yeah? Hopefully that makes sense to you. So if divisible by 5, we'll print buzz instead. So the fizz part should still work just fine. 3, 6. Anything that's not divisible by either still gets printed normally. And now buzz should appear when we type in anything that is a multiple of 5. And now our one job is, what do we do when it's divisible by both? So right now it's 15, and you can take your guess as to what that does. But all right, if it's divisible by both, well, surely I can just do this, right? Else if n divisible by 5, 3 equals 0, and n divisible by 5 equals 0. Boop. See out FizzBuzz. Yeah? Okay, so that's just, it should make perfect sense to you, I hope. If it's divisible by 3, and it's divisible by 5, well then, we're good to go, yeah? Print FizzBuzz. Okay. So I got my 3, fizz, I got my 4, nothing, got my 5, buzz, 15, fizz. Huh. Did you see the problem? Well, let's bring this back with us. Oops. Sorry, it's Control M, not Control N. I think we just need a blank slide, actually. So what's going to happen here is convert this to a flowchart. The first thing it will check, n divisible by 3, question mark? That's the first thing it'll check, right? And if that's true, it'll print fizz and it's done with its job. And then, only then if that's not true, it'll go and try and test divisible by 5. And if that's true, it'll print buzz. And then, if that's not true, then it'll try the last option, or the second to last option. Is it divisible by both 3 and 5? If that's true, it'll print FizzBuzz. And otherwise, it'll just print N. Then it'll hit the else case. Alright, so I hope you see how this translates to that, and I hope you see what's wrong. If this is the first thing that it tries, if it ever needs, it will never hit this case, because it will always, hey, is it divisible by both 3 and 5? Well, that means it was also just divisible by 3, so I'm going to print fizz. Okay, so this is happening too late. We need to put this up here before anything else that's similar to this that might be true before it happens. Okay? So we're going to move them up there. Alright, so that's all we got to do. Link in that. Actually, paste that, then darn. Then we can do n mod 3 equals 0. And just because I want to do this in order, I think I'd rather do 3 first than 5. Just to make myself feel better. It doesn't matter the order of 3 and 5 because they are what's called relatively prime. So this is fizz. This is buzz. Alright. So now, because we're checking this first, because weaker conditions, any of the weaker conditions below would also be true if we check those first. I hope you see that. Oops. So now, we can eat our cake. 3, 4, 5, we get buzz. 6, we get fizz. 9, we get fizz. 10 we get buzz. 15 divisible by both. What? What's going on here? It's quite possible that I just forgot to compile. Oh. I'm so sorry. I think you see my error. That was 10 for some reason. I promise it really does work. There we go. If we do 30 as well, fizz buzz 35 would be buzz. And yeah, it's like 27 is fizz. I hope that you see that this is working now. So if it's divisible by both, that's the first thing that we have to check when we do fizz buzz. If it's divisible by 3, print fizz. Divisible by 5, print buzz. If none of that is true, just print the number n. Okay. Next one. String comparisons and CC type. So these are some things that you might need later. Strings are compared. I showed you that you can do this. Let's give it a normal color. You can do S1 plus S2, and that like puts both next to each other. You can also compare strings. And let me show you what you get. You get this thing called lexicographic ordering, which just really means dictionary order. So, for example, the string, I don't know, ABC is going to be less than BCD. Because how do you compare where something goes in a dictionary? You look at the first letter, and if those are the same, then you look at the second, but if they're not, you compare them. So A comes before B, so this is true. Okay? Alternatively, AAB is less than ABC according to C++. Because the A's are the same, but then the B's, the A and the B, this A wins. It's earlier in the dictionary. And then this will get weird because it really does ASCII order, so like things involving numbers versus letters. Question mark? Let's see what happens. Let's see here. I'll make a new file called, do I just want to say string stuff? Stringstuff.cpp. Alright, so I need to include string because I'm going to use them. And let me print out, is this string A less than the string with just 0 in it? And it'll print 1 for true, 0 for false. And I think, given the precedence rules, I need to parenthesize this. Otherwise it was gonna not be happy with me. Dun dun dun. Oh, sorry, I do need to make these strings. Never mind. Alright, so we're gonna say string A equals that. String 0 equals that. And then we can compare, is A less than 0? Okay. Oops, not fizzbuzz, but string stuff. Not / string stuff. This is actually false. 0 comes before A, so numbers happen. If you go back to the table, numbers appear before letters. So, yeah. 0 is less than A, in fact. A is not less than 0. So this is true, what I wrote. And then the last thing that I want to show you is this CC type library, which allows you to check for whether characters are certain things, like is alpha. That's a nice function. And then also you can convert to upper, to lower, things like that. So you have these functions in CC type, and those will be useful to you one day. So I'm going to give you 2 demos, so convert to a proper noun, and then check if a string ends with a number. Alright. Let's go quickly to, I guess we'll come back to this one. We'll say C++ CC type. Boop. let me show you what's here. All of these functions return Boolean values, true or false. Is alnum, checks if a character is alphanumeric. So you give it a single character. Is it a space character, like a tab or a space or a new line? Is it an uppercase alphabetic character? Okay? Then to lower and to upper, take a character and give you back a character. Okay? Converting that character to either upper or lowercase if it was alphanumeric, or if it was alphabetic. Okay? So let me show you this in action by converting a string to a proper noun. Okay? So here's my string word, and I guess proper nouns are names, so let's use mine. So I want to convert this to a proper noun. So we'll say we need to take the first character, that's at index 0, remember, and to upper it. Okay? So I'm going to say word.at0 equals what it was, but please uppercase it for me. So we'll say to upper. Okay? Just like that. And so this will replace it with what it was, but uppercased. Alright? So then we can print it back out. And you should see a capital L there. There it is. Okay, so that'll convert it to uppercase, alternatively to lowercase. And also, it doesn't care if there's not a letter there. If there's not a letter, it just won't do anything at all. Okay? But if it is a letter, it'll capitalize it. And then the next demo, check if a string ends with a number. Well, let's do that. Here's my string. Let me put a number at the end of it. So to check if a string ends with a number character, we must first figure out how to access that last character. And then we'll call is is digit. All right? Check if it's a digit. 0 through 9. Okay. So, how do we get? We're about to print out what we think. So, if we're putting something right here, we need to put a Boolean expression that returns true or false depending on whether that last character in word is a 0 character. How do we get the last character? Okay, maybe pause the video and think about that. How do we know the index of this last character right there? How do we always know how to get there? Well, let me show you. Here is my string. That's a 0. It's called word. That's what it looks like in memory. These are all its individual characters. And here are the indices of those. Is there a function that we've learned about to know how we can find this index? Well, think about it. And we can get pretty close by asking what is the length of our word. Okay? Dot size, dot length, either one. And it will give us back 1, 2, 3, 4, 5, 6, 7. And we just need to subtract 1 to get the index of the last character. Do you see that? Word.at, word.size, -1. All right, and we're going to check is digit of that. And in our case, it is true, so it will print out 1 for us. That is the number that means true. Okay, so hopefully that makes sense. Please explore that library. It has some fun stuff in it. And now, let's talk about comparing doubles. So let me make a new file called doubles. I'm going to add 10 0.1s together. So that's supposed to give us 1, right? Dun dun dun. So make a file called doubles, and let me just add 0.1 10 times. 2, 3, 4, 5, 6, 7, 8, 9, 10. And I need to print it in a special way with all of its precision. And in order to get set precision, we need to include, remember, IO manip. Input output manipulation. Alright, so now we're going to print D. What is it? Oh, interesting. So doubles are not perfectly precise. It's storing this in 8 bytes. There's only 8 bytes of space, and some numbers are not exactly representable in 8 bytes. And this is one of them, okay? 0.1 was one of them. So adding it 10 times to itself, you end up with a number that is not actually 1. And so, but it's very close, and that's the idea. So what I want to show you here and teach you is never to check for equality. You should instead always check for doubles. I'm talking about doubles. Ints are perfectly precise, of course, for all the numbers that they can represent. When you're comparing doubles, you should never compare them for equality. You should compare them for closeness. So just make sure that they're really close to one another, and that can be equality for you, okay? So if you have D, it's really close to 1, but it's not 1. So the way to discover, hey, on the number line, here is 1.0, here is like 0, 0.5. This number's like right there. How do we check that it's that close? Well, think back to your math class. You'll take the absolute value of the difference between it and whatever number. And just make sure that that's really, really small, for example. Okay? And you can flip these if you wanted. It didn't have to be. It could be 1.0 minus t, because the absolute value will get rid of anything. So that is what you need to check instead of equality. Okay? Because this will be false. Okay? D equals 1.0. That will be false. Alright? Let me just prove that to you. So cout D equals 1.0, and also so that's false, and the thing that we want to use instead is D minus 1.0. Take the absolute value of that, and if we want to use the absolute value, we have to include CMath. That is the double version of the absolute value. And then we're going to check whether or not that was really small, less than 0.001, for example. Okay? That's the idea. So that big thing instead of equality. And that one's actually true. Alright? Hopefully that convinces you to always do that. Alright, more examples, this time with some if statements. So let's calculate some grades. Let's have a user enter a grade in terms of a percentage, and we will output the grade that they receive based on that percentage. Okay? So for example, if it was like 89.5, that's still a B. If it was 42.0, that is an F. Okay? So that's the order, and this is the idea. This is what we want to check. and let me just walk you through this. So maybe, honestly, it's a good idea to pause this and try it yourself, but once you're back, we'll talk about it. Okay. Make a new file, make a new file called grades.cpp. Oh, oops. There we go. And so we'll have the user enter their grade. And the grade will be a double, because it can be a percentage. So now we have it. And now we just need to check. So, okay, I'll put one of those things. That's the idea. So, the order is again important. Well, technically it doesn't have to be, but there's a standard way of doing this, and let me try and show it to you. We can do the A's first. Alright, so if our grade is greater than or equal to 90, or 90.0, whatever you want, if it's greater than or equal to 90, then it's an A no matter what, right? Otherwise, and so remember, we'll only hit this else case if this was not true, which means the negation of a greater than or equal to means it must have been less than, strictly less than 90, okay? And so now we can check, is it within this range? And so we know it can't be 90, but we want to check that it's at least 80. Do you see that? That will be the next thing that we check. Greater than or equal to 80. So this will hit everything that's greater than 80, but was less than 90, all right? And that's the pattern. This is a common pattern that you'll see for the rest of your life. And now we can do the same thing for all the others. And this will be C, and I'll just try and do this. D. For this one, if it was 60, and then otherwise, if it was not at least 60, it must have been strictly less than, and assuming the user didn't type in a negative grade, anything other than these cases, if we didn't hit any of these, and we fell through each time, in that case it's an F, yeah? Please play around with this, that's how you learn it. So that is the idea. That's what we want to print. And it should work. Enter your grade, 92, A. 90, exactly, still an A, but 89.999, it's a B, yeah? 76, 43, 67. Yeah, hopefully this makes sense to you. If grade is greater than or equal to 90, immediately print A. If it's greater than or equal to 80, but it was not greater than or equal to 90, that means it must have been within 80 inclusive and 90 exclusive. Okay? So if we got here, not grade greater than or equal to 90 was true, and grade greater than or equal to 80 was true. Okay? So convert this, remove the not by flipping this. It's strictly less than 90. Okay? That's the idea. Okie dokie. So that's grades.cpp. Let's see how we're doing on time. Alright, let's do a guess the number game now. So this one's fun. I like this a lot. So we're going to ask the user to keep on entering guesses. But first, we're going to pick a random number, and we're not going to tell the user it, between 1 and 100. Okay? I'll call it guess.cpp. So, if we want to use random numbers, we need to include cstdlib And also, if you want to use random numbers that are different every time, we need to include ctime to get the time. Okay, so we're going to initialize our random number generator. We say srand with the time. All right, just like that. And now we can get true random numbers that are different every time we run our program. Okay, so let's pick a random number between 1 and 100. So we're going to say rand mod 100. So then it will be between 0 and 99, but we want it between 1 and 100, so we'll add 1. And I don't have to add parentheses because we know that this one happens first now. All right. Now we're going to ask the user to enter a guess. We'll say int guess cin guess. And I forgot this semicolon, that's why it's unhappy. So now we have the user's current guess as to what the number might be, and we need to determine whether or not they were correct, right? So we don't know the number. The number is just hidden inside of memory right now. We're not going to print it out. So we'll ask the user to enter their guess, and we'll see, was it close, all right? So we want to tell the user if their guess was too high, too low, or just right. Let's do the too high case. If their guess was bigger than what the number really was, then we'll tell them too high. Okay? Otherwise, if that wasn't true, maybe they guessed too low. What they guessed was less than the real number. We'll say too low. And now, if none of those were true, if it wasn't too high and it wasn't too low, there's only one possibility. I hope you see that. In the else case, it must be the case now that guess is equal to number. We don't have to check anymore. We checked enough. There's only one other option. If it was strictly greater than, strictly less than, we tried those cases. We didn't hit that case. So if we're here, the user got it. All right? Oh, oops, I forgot another semicolon. I am so sorry. I guess I do want to keep those like that. All right. Guess.cpp, guess. Enter a guess. 42. Too low, and then the program ends. So if I rerun this program now, it guesses and it picks a new random number. So we want it to keep going. As long as the user is incorrect. All right, so the only thing we know how to do right now, this is perfect motivation for our next thing in this class, is we need to keep asking the user and keep checking. So I'm just gonna do this. All right. Boop. 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 So I'm just keeping asking the user, hey, enter your guess, enter your guess, enter your guess. And eventually, they're going to get it right, I think. So maybe that's enough times. So now I'll just keep repeating, enter your guess. And it'll say if it was too high, too low, or just right. All right, so enter guess, 42, too low. Enter another guess. I don't know. If we were playing this perfectly, you'd have to guess 50 first, right? That's the perfect middle point. Too low. All right, 75. Too low. All right, 95. Too high. 85. Too high. 80. Ooh, it's between 75 and 80. 77. 76. Has to be. You got it. And now, we won the game, but it's still asking us for our guess. So, this was a bad idea. What we should do in the case where the user won is probably end the program. I don't even want that one right now. So now it'll stop the program after we print that. We can say exit 0. And we get this because it's also in the C standard library. So now if we repeat this one enough times, then it'll be okay. Nine. Alright, so that 10 times is probably enough for most people, but there might be a case where you guess in a bad way and you don't actually get at the number. The program ends before you can guess it. So wouldn't it be nice if we could just keep repeating this? 50, 75, 65, 60, ooh, 57, 58. Yeah, and now it stops. It actually stops when we get it because of the exit call. But it's quite possible, if the user isn't good at this game, the program might get here and end before the user won. Wouldn't it be nice if we could keep asking for guesses as long as the user didn't guess the number correctly? That is, guess. As long as guess is unequal to the num, keep going. Wouldn't that be nice? And so that's where I want to leave you. Exercises now. So this is a very helpful one. Please translate this program to a flowchart, so a diagram form. So the first thing that happens, you can think of this like a sub-program of as many lines as you want. So A, then the condition is called B, and then the body of this if statement is C. Then we hit an else case. Inside of that is an if. If that's true, we do E. Otherwise, we check F. If that's true, we do G. Otherwise, we check H. I happens after this entire if statement, then J. All right, so try that, and I'll get you started. So A happens before everything. So first we do A, then we check this condition B, because that's the first thing in this entire if statement. If it's true, we'll do C, and then that's the whole if statement, yeah? And because of that, we'll jump straight to J. J is like at the bottom here, and this is what happens next. All right? If that's not true, we hit the else case. Then we do D. If that's true, we do E. And then, after E, remember that entire if statement in here is now done, and we do I. So then I happens. And then, of course, after I comes J, because then we're done with this entire else statement. So this is kind of complicated, and I want you to try and write it out. Let's see if I can do the rest for you, actually. If that's false, if the if statement here did not fire, we try this one now. We try F. If it's true, we do G. And then after that, we're done with the entire if statement, which means we do I, because that comes after. And then I always ends with J. Okay? If F wasn't true, then we hit this else branch, and we are forced to do H. And then we're done with this entire if statement. Finally, then we do I again, because that's what happens after this entire inner if statement. And then that means we're done with the entire outer if statement as well, and we can do J. Okay, so this is exactly what happens with this program. And I hope, try it yourself, see if you can recreate what I just did and explain it to yourself. But this is something that I want you to know how to do. So please yell at me in office hours if you want me to give you like a simpler example of this to get you to this point, okay? Because that's where I want you to be. All right, then your job, these are optional of course, but please yell at me in office hours if you want to get these working. Write a program to check if a double has a 4 in the ones place. All right, so figure out how you might be able to do that. Okay, one way is converting to a string and finding the dot if it's there at all and looking before it, because you can find indices based on other indices. Alternatively, you can convert this entire number, convert it to an integer. You probably shouldn't round it because that might change the ones place. But convert it to an integer by like chopping off the decimal places, and then you can probably use the mod operator, yeah? So think about those things. And then practice if statements some more. So write a program to check if an int that the user types in is 1, odd and negative, or even and positive. So in case 1, this one, then it's true. In this case, it's also true. So check if either one of those cases is true. Okay, that's the idea there. And then finally, before I let you go, this might be confusing. All of these complicated things might be confusing. The way that your program executes might be confusing. And so please come to office hours. I can totally explain and walk you through how your program will execute each statement. But also, there's this online resource that's really nice. It's called C++ Tutor. So if you go and you search for that, C++ Tutor, the first link, it's this one right here. It's called pythontutor.com/cpp.html. And let me just copy and paste that here for you. I don't think you need this thing after the number sign, but it's probably not going to hurt anything. And so now, this is what you can start typing. You can type your program and click this Visualize Execution button. So let's take a program. Let's see what we got today. Grades.cpp, yeah. All right, then you can type your program. Hit Visualize Execution. And it'll take a hot second because it's got to like analyze your code and figure out what it's doing, and then it'll make a little oh darn, try using the backup server. That's horrible. Usually, there we go, now it works. And so you can now walk through your code. It shows you where it's starting, and you can go next. So it just outputted enter your grade, and it made this variable called grade inside of the main function, and now it's going to ask you for it. Next. Dun dun dun. And then, well, I think we should have given it a value actually. I don't think it's going to ask us for that grade. How about we go back and say, I don't know, double grade equals 42. Okay? Let's try this one. I guess it doesn't support CN, which makes sense. It's got to try and analyze the entire program first. All right, so now grade equals 42 after that line, so it'll now check. It's waiting on this if statement. Next. It wasn't true, so it skipped. Now it'll try this if statement. It wasn't true, so it skipped it. Skip that one, and now it hits the else case. So it prints F to the output, and now the program's over. Isn't that cool? So yeah, I really encourage you to play around with that. It will help you understand how your programs execute, especially when we get into loops. So that, I think, is the rest of these slides, and then I'll come back with another set. So I'll see you later.